Okay, we're on the way. Tell me where we're going.
Okay, so we're going to the state-of-the-art manufacturing facility, right? Like a behind-the-scenes tour. Not many people get to see this.
Oh, fantastic. What do they make?
I'm not positive, but I know it has something to do with making parts for gas turbines. But I know it's cool. I'm excited to see it, so just trust me.
I trust you. Hello.
Hi.
Hello. Welcome.
Hi, nice to meet you.
I'm Steve Woods. Today, I'm going to introduce you to a process called additive manufacturing. It's a state-of-the-art technology, and it all starts in the digital world. So let's go check it out.
All right.
Yeah, let's see this.
Let me introduce you to Cassie and Lindsay. They're responsible for the design.
Ooh, so what are we looking at here?
This model is a part designed specifically for additive.
What are the advantages that using this pipeline provides you guys?
So there's several advantages, the first of which is saving time. It also allows us to add in these really complex geometries that you can only do with additive.
So all of those napkin drawings that you couldn't do before, now you can print them.
Come on in, Cass.
Oh, man.
Look at these things.
These are all printing machines, right?
Yes, these are all metal additive manufacturing machines.
What kind of metal do most of these use?
So we are using cobalt and nickel-based alloys for gas turbine hardware.
Hold on. There's some geekiness going on. This machine's named Storm, and that's Wolverine. These are named after the X-Men.
Do you actually refer to them by these names?
Yes, we do.
You do?
Yes.
You nerds.
So this is Havoc.
Just put your parts in, and 60 hours later, you know,
60
we have
hours.
For the smaller builds.
Yeah, for the smaller builds.
Oh, yeah.
The way the process works is it's 2D laser scanning, each one of the layers. So 3,000 to 7,000 layers, depending on the parts that we build. This becomes layered-based manufacturing.
So the machine deposits a layer of powder on the build plate, and a laser comes out and draws a pattern. More powder is deposited, and the laser scans again. And 7,000 of those later, you end up with a magical, really cool part.
Plus or minus, yes.
Wow.
I can show you what we're going to be printing.
Can you make sure that I get a window seat on the...
Now that's all I'm going to see every time.
Sorry for the virus.
These are actually the support structures to the part that I'm printing.
Oh, so this is literally an outline of the first layer.
The first layer.
Out of how many?
3,308. Wow. And you ready to hit start?
Yes.
Start that build
Double-click.
up.
Double click.
Oh, look at that. That is gorgeous.
It is indistinguishable from magic. You guys have any discretionary printing that you can do, like a gift for your grandmother or something like that in these?
Yeah, your wedding rings?
So about that, I did print my my husband's wedding band.
I called it.
Well done.
I called it.
It takes 63 hours to build this part, so we're stepping over to another machine to observe the results of what we built.
Right away.
Right away.
It's like a cooking show.
But first, your safety equipment. It's hard to look good and be safe, but we will succeed. Boom.
I feel gorgeous. We can see inside? We can touch it? Yeah, you can touch it.
Oh my God. Oh, it feels so cool.
It feels like cornstarch, kind of.
Yeah, but really heavy cornstarch.
Yeah. So you have to clean this entire project out.
Yes, Allie, get started. It'd be great.
This is a cool chore. I like this. I'm into this chore.
One of the beautiful things about additive is you only need to use the material that you need for the actual part. So we attempt to reuse as much of the powder as we can to make the process more efficient and have less waste.
We'll end up turning on a vacuum. It's loud.
Oh, there it goes. Oh, it's like an hourglass. I am clearly a novice at this.
All right. Now that we've finished vacuuming it out, we got the last check to make sure we've got all of the powder evacuated.
What is that?
Allie's gonna hit it with a hammer.
I get to just whack this thing?
You get to whack it. If there's any powder on the white piece of paper, we have to start over. This is a very low-tech solution for a very high-tech problem.
All right, this is for the time they canceled my flight and I had to sleep in the airport. You got anything?
No.
Looks like we passed.
And now, is this welded to the base?
The parts are welded to the base. We gotta cut them off that plate.
How do we do that?
It's called an EDM wire.
Oh, I've always wanted to watch one of those go. Oh, so cool. This seems slower than I thought. How long is this cut going to take?
This is going to take about 8 hours to run.
8 hours!
So here's the finished part. It's all done.
Amazing. Okay. What is it?
Yeah.
Wait.
Only questions.
This is what we've been wondering since the beginning.
So this is the part that goes inside a gas turbine, and it creates a seal between the blades that spin around and the case that it sits into. These holes that you see, they kind of crisscross back and forth over each other inside the part. You can't make those with traditional machining.
So by creating this with additive manufacturing, you can increase the efficiency of the whole turbine?
Absolutely.
Can we possibly see what this goes into and how it fits in?
Yeah, absolutely.
It's hard to take it all in.
I know. Oh, my word.
Wow.
That is not small.
No.
So what do you think?
It's astounding.
Amazing.
So the additive manufactured part that we walked you through today
Yeah.
will be installed into this bigger assembly to power hundreds of thousands of homes more efficiently.
That's a pretty big deal.
That's what we do.
Incredible.